All right, hello everyone. So today we're finding the following limit with the aid of L'Hopital's rule. Have the limit as x approaches 1 from the left of the quantity x minus 1 times the cotangent of pi x. All right, so first thing we want to do is see the behavior of our function as x approaches 1 from the left. So if you approach 1 from the left, the x minus 1 part would approach 0, and the cotangent pi x part would approach negative infinity. More into that, as you approach 1 from the left for the pi x part, that would approach pi, a little bit smaller than pi, and you would then see what the cotangent of those values is, and as cotangent approaches pi, you would get that you go to negative infinity. And I get that, you can look at that at the graph, and I often tell people if you have trouble finding what the value of something is a limit, look at a graph of trig function and such as we did. All right, so 0 times minus infinity, or 0 times infinity, is an indeterminate form. An indeterminate form is a form for which you don't know what the limit is unless you do a little bit more investigation, if you can, a little bit more algebra a lot of the time or calculus in the matter here. And those forms are 0 over 0, infinity over infinity, infinity minus infinity, infinity times 0, 1 to the infinity, infinity to the 0, and then finally 0 to the 0. L'Hopital's rule is our tool that we're going to use. However, L'Hopital's rule only works if you have the form 0 over 0 or infinity over infinity. We don't have that here, but we'll get to that. And just as a review, what L'Hopital's rule says, if you take the limit as x approaches a number of a ratio of two functions, and you get 0 over 0 or infinity to infinity, then the limit as x approaches a can be a number or infinity or negative infinity, can approach from the left or right, of f over g is equal to the limit of the derivative of f over the derivative of g as x approaches the value a. All right, so we're going to use that here. Let's write our problem one more time. And I'm sorry, this is a cotangent. And here's how we're going to do this. I'm going to rewrite this function as a ratio. These two functions, this one and this one, are equivalent. If you take this one and you divide it, you flip it, you would get what you have on top. So the key thing here is one of the functions stays on the top, and one of the ones goes down under the function that you kept on top. And I'm gonna go over in a second why I picked what I picked. But let's finish this problem out here. 1 over cotangent is like saying tangent of pi x, and I write it this way just because I think it's easier expression to work with for when we take a derivative. And as x approaches 1, you'll get 0 over 0. Okay, and now I could use L'Hopital's rule. So that was the whole point for me to do that. It's just I can use, when I rewrite it as a fraction, get it down to a point where I can use L'Hopital's. Derivative tangent is secant squared pi x times pi. As you approach 1, you get the secant squared of pi. Secant of pi is negative 1 squared is 1, times pi is pi, so you get 1 over pi. So that is what your limit would equal, 1 over pi. Now, and that's the whole thing. The original limit would equal 1 over pi. Now, going back to what I said earlier, why did I pick this instead of me rewriting this as maybe having the cotangent on the top and the 1 over x minus 1 on the bottom? Now, this can certainly work as well, but I often notice that this one method works out pretty nicely, the other one doesn't work out as nicely when it comes to finding the derivative and getting the result, and simplifying a lot of the cases. Like with these limits, you have to simplify in order to get an answer out. Yeah, this would not work out too well. I because of time constraints, I can't do it here, but I suggest you try to find this limit here and see how that compares to what we just did a second ago. And in general, we don't have like set rules, but when you have for example, a trig function and a polynomial that you're taking the limit of, yeah, usually having the polynomial at the top over the trig, 1 over the trig, that's a pretty good job. If you have a natural log times almost anything, you want to usually keep the natural log on the top and put the anything under 1, okay, whatever that function it might be. And these are just, you know, tips. There's nothing like, I mean, we can go a little bit more into the rigor, but it's not super rigorous. It's just things that have helped me out throughout the years. All right, so I hope this helps. Thank you very much for your time.